geometry, folks. Let's keep moving on our unit on triangles. Yay! I love triangles. So the unit covers a whole bunch of stuff. We're getting into triangle congruence. So what is it that we're going to talk about today? We're going to talk about just two triangle congruence theorems, just side, 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 and side, angle, side congruence. So what we're going to accomplish is using the side, side, side congruence theorem and the side, angle, side congruence theorem. And then what we'll do is work on identifying congruent triangles. So let's jump into this. Now, the last lesson we left off with, we talked about proving congruence by using all of the parts of triangles. And so we got a couple of postulates here that we're going to use. And basically, we're going to say, well, maybe we don't need all 6 congruent parts to prove congruence. And that's exactly the case. So we got two postulates we're going to talk about. The first one is the side, side, side congruence postulate. And we're going to talk about, well, if there are 3 sides of one triangle that are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. Okay, so there's a couple diagrams to prove that. But the most important thing to say is right here, that correspondence matters. Okay, so AB corresponding to DE, and AC corresponding to DF, and BC corresponding to EF. So those 3 being congruent to one another, we need all 3 sides in order to prove congruence. So if we have 3 congruent sides, then we have 2 congruent triangles. Okay, so maybe we don't need all 6 congruent parts from that last lesson. That's why I called it a long cut. This is one of the shortcuts. So if you have 3 sides, you're all set. Now, there's another postulate where it gets kind of tricky. There's another postulate called side, angle, side congruence. The reason why this is tricky is because, again, first of all, correspondence matters. And then secondly, we have to talk about if 2 sides are included and the included 2 sides and the included angle is congruent to the other 2 sides and the included angle. So look what's happening in this note. So we have the 1 tick mark here, right? So 1 tick here and then 2 tick marks here. The included angle is between them both. Okay, that's called included. So that's the included angle, and that is so important. And that's why we call it the side, angle, side postulate, because check it out. It's like how we read the thing, right? We got a side, an angle, and a side. A side, an angle, and a side. That's why we call it side, angle, side. Side, angle, side. Side, angle, side. Okay? Okay. So if that was too fast, totally pause and rewind. But these are the 2 notes we're really going to focus on for this lesson. Okay? So side, 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 and side, angle, side. Now, let's have some fun. Yay! Don't cheat. I didn't mean to show you all that. There. Just that. Here, I'll hide some stuff. So what we're going to get into is a side, side, side postulate. We're going to get into a proof already. Wait, what? Did you say proof? Yeah. And we're just going to jump right in. We're going to talk about using the side, side, side postulate. So we have this given statement here where the segment LM is congruent to segment NP and segment LP is congruent to segment NM. Those are given statements. We're going to prove the 2 triangles congruent. So here's this diagram. Now I ignore that because I kind of drew that myself. So here's that diagram, and what we're going to do is write a proof. Okay, so we have our statements and our reasons. Now when we look at this diagram, let's have a game plan, right? So we have 2 triangles here, and we're going to prove that triangle LMN is congruent to triangle NPL. We're going to prove these 2 triangles congruent. Clearly, we're going to use the side, side postulate. So what is it that we're looking at here? So here's a helpful hint. If we have our 2 triangles, right, LPN, I rewrote this, LPN, I drew that triangle here, and then we have the other triangle, NML, and again, I drew it NML, and we know what is congruent, right? We have LM and NP congruent, right? I put the 1 tick there, and then we have LP and NM congruent, so the 2 ticks there. How are we going to prove these 2 congruent? Well, let's come up with a game plan. The game plan is this. If we had these third sides congruent to each other, we would have, right, we would have 2 congruent triangles. It's side, 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 right? But the trick is, how in the world are we going to show that these 2 sides are congruent to each other? So let's jump into the proof, and then we'll get there when we get there. So the first thing we talk about, let's start with the given statements. Now, I'm going to go ahead and cheat a little bit and shorten this thing up. I'm just going to I'm just going to throw all the given stuff right there. There it is. So as long as I know what it's saying. So what does this saying? LM is congruent to NP. All right, got that. And then LP is congruent to MN. Okay, got that. So I'm basically just stating what's in the pictures. So now there's nothing that's in the pictures not written down. If only we can show, dagnabbit, if only we can show these two sides are congruent to each other. Well, look at the original diagram. These two sides, LN and NL, it's right here. It's the same side, right? Totally the same side. So now we're going to jump into a really key element here. And the key element we're going to jump into is the fact that those two sides, LN and LN, are the same thing. Okay, so here's the kicker. And I put a star next to it. The kicker is that segment LN is totally congruent to segment LN. It's congruent to itself. That's the kicker statement. And we must establish that. That is very important. So I put the star there. We must establish it. We can't overlook it. We have to establish it. So what is the reason for saying this? And then, we have a trip down memory lane. Hopefully you're thinking about it before I show it. What's the reason I can say that this side is congruent to itself? You ready? I hope so. The reflexive property of congruence. That is the kicker. Okay, this is totally the kicker to the proof. And we must establish it. We can't overlook it. So we must establish that segment LN is congruent to itself. And once we establish that segment LN is congruent to itself, look what I can do in the diagram. I can give it 3 ticks, right? Or in the picture that I drew over here, again, I can give it 3 ticks on that, 3 ticks on that, and look what we have, kids. We have 2 congruent triangles. So guess what we've done? We've now established the proof, right? We have totally. Now we're able to say the 2 triangles are congruent to one another, right? Totally congruent. Now, why can we say that? Well, because we have sides congruent. You can say side postulate. You can say the 2 triangles are congruent since all 3 sides are congruent. The 2 triangles. I don't care how you say it, but well, I kind of do. But it's important that we establish that we have side congruence, and that means that can justify that the 2 triangles are congruent because all we need are the 3 congruent sides. So that's how a proof of that magnitude will work. Okay, so that's how we're proving with side postulate. Now I ain't done with you yet. Let's do another one. Let's do another one. So here's another proof, right? So I have again a diagram and some given things: BC congruent to BF and CD congruent to FD, and we're going to prove these 2 triangles are congruent. So I hand drew again the sample. So I hand drew this. This is basically what we're looking at. So how in the world, what's the game plan? How are we going to prove these 2 triangles congruent? Hopefully you see it's the same thing we just did. So how would this proof look? Well, we start with a given, and again, I will just go ahead and write out the whole given stuff. I don't need to do it piecemeal. Just write out everything that's given, because I'm going to use it all right now. I'm not going to piece it. I'm just going to use it all right now, which is why we can do that, because we're going to write it all down. So if we have those 2 things established, what's the game plan? What's the end game? The end game is that if we can get this 3rd side congruent to each other, or this side congruent to itself, we would have our congruent triangle. So again, the game plan, if I can get this congruent to these 2, if I only had this, I'd be ready to go. And the good news is, well, I can do that because the kicker, segment BD, is congruent to itself. Why can I say that? Because of the reflexive property of congruence. And again, I have that kicker statement, that kicker reason. That's the hard part, right? So I can completely say that this side is congruent to itself, and then these sides are congruent to one another. And that's side congruence. So now that I have side congruence, I know all 3 sides are congruent. My proof is proven, right? I'm done. So mic drop, right? We're finished. And that, my friends, is side congruence. So yes, proofs are in action. We're coming back. So let's talk about side angle side postulate, shall we? Why, yes, Mr. Katz, we shall. So here's a question. We knew about side angle side. We talked about the note, and the note about side angle side had to do with two congruent sides and the included angle. And remember, correspondence matters. Okay, so we revisit that. So the two congruent sides, the included angle matters. So now we have this question here. What other information do we need to prove that triangle DEF, remember, reading matters. We're going to assume that this is EF. So we have DEF is congruent to triangle FGD, right? So look at how we're reading this triangle. We're reading this triangle this way. Okay, so triangle DEF is being read DEF, and then FGD is being read this way. Reading matters. Okay, so look at how the triangles are being read. Reading matters. So what other information do we need? Well, the first piece of information, hopefully you can tell, is that segment DF is congruent to itself, right? That's a helpful thing. Segment DF is congruent to itself. So now we have this side, and then we have this side, and these two are corresponding. So let's draw that picture out. Let's see what would happen. So if we were to draw the picture out and see what goes on, it'll help us, I think, a little bit anyway. And so we have E in the corner, let's say D up top and F out here. And then on this one we have G in the corner, and then that would be D up top, and F up top, and D out here. Okay, so what do we know? We know that DF is congruent to DF, and then DG is congruent to DE. Actually, wrote it cockeyed. So what do we need to know? We have to know that the included angle is also congruent, right? So we have the two sides, right? So we have this side and this side. They're corresponding to one another. We need to know the included angle is congruent. So remember, the reflexive property is how we can show that DF is congruent to itself, right? So with the reflexive property, we know that segment DF is congruent to itself. So what are we missing? What are we missing? In the diagram here, we're missing the included angle. So we're missing the included angle. In this case, we're missing this angle being included and this angle being included. That's what's missing. And so we have to be able to show that those included angles are congruent, and we'd be all set. So we have to show the included angle. So the question is, what other information do we need? We need to know that DF is congruent to DF, which we already know that. We don't need to know that because we already know that. But what we really need to know is that this angle here, down here, angle FDG, make sure we remember how to read angles. So angle FDG is going to be congruent to angle DFE. Okay? And so that's the missing piece. So what do we need to know? We need to know that included angle is congruent, and that is side angle side, because reading matters, and that's what included means. All right, so if that was too fast, again, pause, rewind. You can do that. So let's jump into another question. So again, the question is similar. What other information do we need to prove that these two triangles are congruent? So we have triangle LEB being read this way, right? And then triangle BNL being read this way. Okay, so important that we read the triangles the right way. Now, how are we going to prove that these two triangles are congruent by side angle side? That's what we're missing. So all we have is the included angle, right? So we have an included angle here. And what else do we already know? We already know that this side is congruent to itself. We already know segment LB is congruent to segment LB. Trust me, that's LB. Don't mind my handwriting. We already know that, so what would we be missing, right? In order for these angles to be included angles, we would have to be able to show that the angles are included between two sides. Okay, so these are the sides that we have to show right here, this side and this side. Those would be the sides that we have to show. So what's the information that's missing? We would need to show that segment LE is congruent to segment BN. Okay, that's what we would have to show. That's what we're missing. So with that missing information, we would have our congruent triangles. And that is what side angle side looks like. Okay? Okay. Again, too fast, pause, rewind. Now let's do some pop quizzes, shall we? What would we use? Side, 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 or side angle side to prove these triangles congruent? So let's look at example A. We have a 2-mark side, an included angle, and a 1-mark side. Okay, so 2, angle 1. 2, angle 1. Guess what? That's side, angle, side. The angle is definitely included. So this, no doubt, is side, angle, side. Okay? And now we look at question B. What's going on here? We have 2, angle 1. 2, 1, angle. In the second triangle, we don't have an included angle. This angle is not included. Okay? So if that angle is not included, do we use side, angle, side, or side, side, side? We actually use neither. None of the above. Trick question. Gotcha, punks. So, fooled you. For question B, we're not using either side, 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 or side, angle, side, because this one's included, this one's not included. We have to see that difference. Okay, so now for question C, hopefully you see we got 3 corresponding to 3, 1 corresponding to 1, 2 corresponding to 2. No doubt, dude, this is totally side, side, side congruence. And then the same thing with D. We got 1 corresponding to 1, 2 corresponding to 2, and 3 corresponding to 3. This is totally side, side, side. And so that's how we would use, again, being able to train our brain to see where we can use these congruence theorems. Too fast? Pause, rewind. Moving on. So the next question is here. Would we use side, 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 or side, angle, side to prove these two triangles congruent? Let's explain. So the first triangle, we've got a 1, a 3, and a 2 hash mark. And the second one, we also have a 1, 2, and 3 hash mark. In the first triangle, we have a 1 arc angle. In the second triangle, we have a 1 arc angle. So it looks like we have a pretty good choice, right? If we could use either one, it kind of looks like. No doubt, though, we have side, side, side. Not a doubt at all. Because if you look at this triangle here, notice how the 1 arc, or the 1 tick side is on the left. I can rotate this around, and it would be the same thing. We're not letting gravity mess with us. So everything would be corresponding if I just turned it around. Right, so the sides are all set. Like, no doubt we have side, side, side. But do we have side, angle, side? So let's look at the first angle. This is included between 2 and 3. Okay? So this is included between the 2 marks and the 3 marks. So that's the included angles between 2 and 3. So in order for us to be able to use side, angle, side, this would have to be included between 2 and 3. And is it? No. This is included between 1 and 2. Okay, so the 2 congruent angles are not included on the same angle, so we can't use side, angle, side the way it stands, right? We could do some work and eventually get there, but that's not the point. The point is, right now, as things are, could we use side, 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 or side, angle, side to prove the triangle is congruent? And the way things are, the congruent angle is not included, so we'd have to use side, side, side as our reasoning, and that's how that works. Okay, moving on. Let's do a quiz, shall we? So here's what a quiz would look like. So we got this big shape. What other information do we need to prove GHK congruent to KLG by side, angle, side? Okay, so this is the key. We're gonna prove side, angle, side. Remember, reading matters. GHK, which way is that being read? GHK is being read this way, and then KLG is being read this way. So what do we currently know? We currently know that we have our 2 sides congruent, and we know by the reflexive property that that diagonal side is congruent to itself. So we know that. We have to now prove the included angle. So we have to show the included angles being congruent. That's what we have to show. That's the other information we need. And so the only question is, well, which one of these reads that, right? So we have to look at angle LGK and angle GKH. So we're going to look for LGK and GKH. That doesn't exist, so maybe we have to read it the other way. How about angle KGL and angle GKH, right? So how about GKH and... Look at this, is all crazy, right? So how about we just use this one, KHG, is that one? No. How about HGK, is that one? No. How about angle GHK, is that one? No. How about angle HKG, is that one? Yes. So we have angle HKG and angle LGK, so it must be D. And that's how we're going to use that particular question. One last question for a quick quiz, and then we'll be all set. So this one has a lot of words, right? But we have this diagram here. The diagram is, would we use side, 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 or side, angle, side to prove the triangle And if there's not enough information, choose not enough information. And so we have this diagram, and we can either pick not enough information, side, angle, side, or side, side, side. So which one will we use? Hopefully this one's nice and easy. Reflexive property of congruence. And now we know that side is congruent to itself, so we have side, side, side. Must be C. Okay? Okay. So that is us pounding through triangle congruence using side, 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 and side, angle, side. I hope you enjoyed this. If not, I don't know, go back and rewind, because I know it's chock full of good info. I'm out of here. We'll continue on with more cheats later.